Hello everyone, welcome to Creative Civil Engineering Coach. In this video, I'll be discussing about PGCET 2018 Civil Engineering question paper. So let's begin with part 1 questions. Question number 1. Creep strain is. Creep means when the length of the bar keeps on changing at constant load, which is caused by static load. Out of these given options, the constant and static load is dead load only. So creep strain is caused due to dead load. Option A is the right answer. Question number 2. The effective length of the column of a length L fixed against rotation and translation at one end is. So when the column is fixed at one end and translation at another end, the effective length of the column will be 2 times of the original length of the column. So the right answer is option D. Question number 3. The ratio of theoretical critical buckling load for a column with fixed ends to that of another column with the same dimension and material but with pinned ends is equal to. So we have to determine the ratio between the two different end conditions. The general buckling load formula is n square pi square EI by L square, where n depends upon the end conditions of the column. So when the columns are hinged, n is equal to 1. Therefore buckling load will be pi square EI by L square. When the both ends of the column are fixed, n is equal to 2. Therefore buckling load will be 2 square, which is nothing but 4 pi square EI by L square. So we have to find the ratio between these two end conditions, which is equal to, let us assume this as PCR1, this as PCR2. So PCR2 divided by PCR1, which is equal to 4 pi square EI by L square divided by pi square EI by L square. So the required ratio is 4. So the right answer will be option D, 4. Question number 4. When the middle pontoon is removed, the deflection at H will be. Pontoon means it is a flat bottom portion of the boat which is used to support a temporary bridge. In this question you can observe they have not given any type of the figure to find the deflection at point H. So for this question it was declared as a grace marks. But when I searched in the topic of engineering mechanics, this was the expected question with the following figure. So by assuming the following data, let us try to solve this question. So here they have mentioned the sectional area of each pontoon is given as 8 meter square and flexural rigidity of beam is 10,000 kilonewton meter square and the unit weight of water is 10 kilonewton per meter cube. By assuming these following data, let us try to find the deflection at point H. When the middle pontoon is removed, the force P will be resisted by pontoon G and I. So at point G and I, the reactions will be half times of the total concentrated load, which is equal to 24 kilonewton. According to flotation principle, reactions at support is equal to weight of the displaced liquid by pontoon. So 24 kilonewton is equal to volume of the water multiplied by unit weight of water. 24 kilonewton is equal to area multiplied by displacement of the pontoon. Unit weight is 10 kilonewton per meter cube. Therefore area is given as 8 meter square. H into 10. This is 24 kilonewton. So height or displacement at point H is equal to 24 kilonewton divided by 80, 0.3 meter. Now we have to find the elastic deflection at H due to load. So it is given by the formula PL cube by 48 EI, where P is the total concentrated load, L is the total distance between the pontoon, that is 5 meter plus 5 meter, 10 meter. So 10 cube divided by 48. EI is the flexural rigidity, that is 10,000 kilonewton meter square. On solving this, the elastic deformation will be 0.1 meter. Therefore, the total deflection or total height is equal to 0.3 meter plus 0.1 meter, which is equal to 0.4 meter. So the right answer is option B, 0.4 meter. Question number 5. The components of strain tensor at a point in a plane strain case can be obtained by measuring longitudinal strain in the following direction. In a plane strain case, component of strain tensor at a point are strain along x direction, y direction and z direction. So to find out the component of strain tensor, we measure longitudinal strain along 3 arbitrary directions. So the right answer is option B. Question number 6. The degree of static indeterminacy of a rigid frame having 2 internal hinges as shown in the figure below is. These are the 2 internal hinges. The degree of static indeterminacy for a rigid plane frame is given by 3c minus r dash. R dash is the number of restraints. For a fixed support, the number of restraints is 1. For a roller support, there are 2 restraints. So 2 plus 2. Neglecting the axial deformation, there are 2 axial deformations. So 12 minus 7. So the degree of static indeterminacy will be 5. Option D is the right answer. Question number 7. Muller-Breslau principle in a structural analysis is used for. Muller-Breslau principle can be used to determine the shape of the influence line, which indicates the part of the structure to be loaded to obtain the maximum effect and to calculate the ordinates of influence lines. So the right answer is option A. It is used for drawing influence line diagram for any force function. Question number 8. For a linear structural system, minimization of potential energy yields compatibility conditions. These compatibility conditions are mathematical conditions which determine whether a particular deformation will leave a body in a compatible state. So the right answer is option A. Question number 9. The stiffness coefficient Kij indicates. Kij is any element of the stiffness matrix, which means force at point I due to unit deformation at J. So the right answer is option A. Question number 10. The maximum auging moment in beam anywhere is. In this question you can observe they have not given any type of the beam figure. So we can't solve this question. So this was given as a grace mark. Question number 11. Consider 4 common air pollutants found in urban environments: nitrous oxide, sulfur dioxide, soot and ozone. Among these, which one is the secondary air pollutants? Secondary air pollutants are those pollutants which develop from the interaction of primary pollutant and atmospheric constituents. The example of secondary air pollutants are ozone, smog, formaldehyde and sulfuric acid. So ozone is the secondary air pollutant. Nitrous oxide, sulfur dioxide and soot are primary air pollutants. Question number 12. A coastal city produces municipal solid waste with higher moisture content, higher organic materials, low calorific value and low inorganic material. The most effective and sustainable option for municipal solid waste management in that city is. So if the solid waste contains with higher moisture content and higher organic materials, the best method will be composting method. Option A is the right answer. Incineration method will be adopted when the calorific value of the municipal solid waste will be high. So calorific value will be high in incineration, and landfill method is adopted when the density of the solid waste or municipal solid waste is high. So this is adopted when the density of the solid waste is high. Question number 13. What is the solid content by weight of a thickened sludge? 100% of the sludge is equal to 2% of the solid content plus 98% of the water content. So the volume of the sludge is equal to 2% of solid content, means 2 divided by 100 multiplied by its specific gravity. So 2.2 is the specific gravity of the solid content. 98% of water means 98 divided by 100. 1 is the specific gravity of water. So the volume of the sludge is equal to 0.0989 meter cube. After the sludge is thickening, the volume of the water will be changed. So the new volume will be half times of the original volume. So it is 0.0989 divided by 2, which is equal to 0.04945 meter cube. Therefore, the new volume after the sludge is thickened, that is 0.04945 meter cube, is equal to volume of water plus volume of solid content. So volume of the water is x%, so x divided by 100 into 1, plus volume of the solid is 2%, so 2 divided by 100, specific gravity is 2.2. So on solving this, the volume of the water, that is x, is equal to 48.545%. This is the volume of water. Now we have to find the percentage of solid content by weight. So solid content is equal to 2 divided by 48.545 plus 2 multiplied by 100, which is equal to 3.96%. Question number 14. The cumulative noise power distribution curve at a certain location is given below. The value of L40 is equal to, L40 means the noise level which is exceeded 40% of the time. Slope of the given noise power distribution curve will be 100 minus 0 divided by 100 minus 50. So the slope of the given noise power distribution curve will be 2. Similarly, to find out noise power which is exceeded at 40% time means slope is given as 2. So 40 minus 0 divided by L40 minus 50. 2 into L40 minus 100 is equal to 40. 2 times of L40 is equal to 40 plus 100. L40 is equal to 140 divided by 2. So the noise level which is exceeded at 40% is equal to 70 dBA. So the right answer is option C. Question number 15. Zero hardness of water is achieved by. Zero hardness is achieved by ion exchange method only. It is also called as zeolite process of base exchange treatment. So the right answer is option C, ion exchange treatment. Question number 16. For a subcritical flow in an open channel, the control section for gradually varied flow profile is. For a subcritical flow, the Froude number is less than 1, which means that Froude number is less than ratio of viscous force divided by gravitational force, which means that square root of gravitational force is greater than viscous force. Therefore, the velocity of the wave is more than velocity of the flow. So, for a subcritical flow, the control section for gradually varied flow profile will be at downstream end. Option A is the right answer. Question number 17. The normal depth in a wide rectangular channel is increased by 10%. The percentage increase in discharge in the channel is. We know that flow rate or a discharge in the rectangular channel is given by area into velocity. Area is B into D, that is breadth into depth. Velocity is calculated by Manning's formula, that is 1 by n r to the power of 2 by 3 s to the power of 1 by 2, which means that discharge is directly proportional to y to the power of 5 by 3. So for the case first, discharge is equal to k into y1 to the power of 5 by 3. For the second case, if the discharge is increased by 10%, q2 is equal to 1.1 times of y1 to the power of 5 by 3. So we have to find percentage increase in the discharge, which is given by q2 minus q1 divided by q1 into 100, which is equal to 1.1 times of y1 to the power of 5 by 3 minus y1 to the power of 5 by 3 divided by y1 to the power of 5 by 3 into 100. So the percentage increase is 0.1 divided by 1 to the power of 5 by 3 into 100, which means that it is 17.22%. So the right answer is option D. Question number 18. A rectangular open channel of a width 5 meter is carrying a discharge of 100 meter cube per second. The Froude number of the flow is 0.8. The depth of the flow in meter in the channel is. We know that discharge is given by area into velocity. So velocity is equal to discharge is 100 meter cube per second. Area of the rectangular channel section is breadth into depth, that is 5 meter into depth y. So velocity is equal to 20 by y. Let us consider this as equation 1. From the Froude number relation, we know that it is a ratio of viscous force divided by gravitational force. So velocity is equal to square root of gravitational force into Froude number. Let us consider as equation 2. From both these equations, square root of 9.81 into y into 0.8 is equal to 20 by y. Square root of 9.81 into y is equal to into y is equal to 20 divided by 8 into 10. Square root of 9.81 into y is equal to 25. Squaring on both the sides, 9.81 into y square is equal to 25 square. Therefore y cube is equal to 625 divided by 9.81. Therefore y is equal to 625 divided by 9.81 to the power of 1 by 3, which is equal to 3.99 meter, approximating as 4 meter. So the right answer is option A, 4 meter. Question number 19. In the Bernoulli's equation used in the pipe flow, each term represents energy per unit mass. Option B is the right answer. Question number 20. A hydraulic jump takes place in the triangular channel of a vertex 90 degree as shown in the figure. The discharge is 1 meter cube per second and the pre-jump is 0.5 meter. What will be the post-jump depth, taking acceleration due to gravity as 9.81 meter per second square? So we have to find the post-jump depth, that is y2 is equal to how much? y1 is given as 0.5 meter. Discharge is given as 1 meter cube per second. We know that the specific force will remain constant on both the sides of hydraulic jump. So q square g a1 is plus a1 z1 is equal to q square g a2 plus z2 a2. Z is the datum height. So z1 is equal to y1 divided by 3 and z2 is equal to y2 divided by 3. For z1, y1 is given as the pre-jump depth, that is 0.5 divided by 3, and a1 is given as 0.5 square. On substituting these values, 1 divided by 9.81 into 0.5 square plus 0.5 square into 0.5 divided by 3, 1 divided by 9.81 into y2 square plus y2 divided by 3 into y2 square. On solving this equation, the post jump depth will be 1.02 meter. Option C is the right answer. Question number 21. Deposit with a flocculated structure is formed when? Flocculated structure is present in the clay particles which contains larger surface area. So it is formed when the clay particles settle on the freshwater lake bed. Option B is the right answer. Question number 22. The ratio of saturated unit weight to the dry unit weight of the soil is 1.25. If the specific gravity of the solids is 2.65, then the void ratio of the soil is. Ratio of saturated unit weight to dry unit weight is given as 1.25 and specific gravity of the solids is given as 2.65. We know that the saturated unit weight is calculated by G plus SE 1 plus E into unit weight of water, and dry unit weight is calculated as G into gamma W divided by 1 plus E, which is equal to 1.25. For a saturated soil, S is equal to 1. So by rearranging the following formula, we will get specific gravity of solid plus void ratio divided by specific gravity of the solid, which is equal to 1.25. So void ratio is equal to 2.65 into 1.25 minus 2.65, approximating this as 0.663. So the right answer is option B. Question number 23. The void ratio at the densest, loosest and natural states of the sand deposit are 0.2, 0.6 and 0.4 respectively. The relative density of the sand deposit is. Relative density is a measure of compactness of cohesionless soil and it is calculated by the following formula. So maximum void ratio is 0.6, natural void ratio is 0.4 and minimum void ratio is 0.2. On solving this, the relative density of the sand deposit will be 50%. So the right answer is option C. Number 24. The following data was obtained from a liquid test conducted on a soil sample. The liquid limit of the soil is. Liquid limit is the minimum water content at which soil has the tendency to flow. So liquid limit is taken as the water content corresponding to 25 number of flows. So for 25 number of flows, the water content is 61.9%. Therefore, liquid limit will be 61.9%, which is corresponded at 25 number of blows. So the right answer is option C, 61.9%. Question number 25. A 25 kN point load acts on the surface of an infinite elastic medium. The vertical pressure intensity in kN meter square at a point 6 meter below and 4 meter away from the load will be. So according to Boussinesq's equation, the vertical pressure intensity is calculated by the formula 3q divided by 2 pi z square into 1 divided by 1 plus r by z square to the power of 5 by 2, where q is the intensity of the point load, that is 25 kN, and z is the vertical distance, that is 6 meter, so 6 square. R is the radial distance, that is 4 meter, so 4 divided by 6 square to the power of 5 by 2. So the intensity of vertical pressure will be 0.132 kN meter square. Option D is the right answer, 0.132 kN meter square. Question number 26. Camber on highway pavement is provided to take care of. Camber means it is a slope provided on the road surface in the transverse direction to drain off rainwater from the road surface. So it is mainly provided to take care of drainage. Option B is the right answer. Question number 27. The minimum value of CBR in percentage required for granular subbase as per Ministry of Surface Transport specification is. It is 5%. Option A is the right answer. Question number 28. The design value of lateral friction coefficient of highway is. Lateral coefficient friction acts to counteract the centrifugal forces acting on the tire in the lateral direction, and the value of the lateral coefficient friction as per IRC is taken as 0.15. So the right answer is option D. Question number 29. Bitumen is derived from. Bitumen is obtained from fraction of distillation of petroleum products. So it is a fractional distillation of petroleum. Option C is the right answer. Question number 30. The speed and delay studies on a defined section of highway are conducted by. The speed and delay studies are conducted by moving car method. Option C is the right answer. Question number 31. Road roughness is measured using bump integrators. Option B is the right answer. In the following figure, you can observe the bump integrators installed to measure the roughness of the road. They are now commonly installed on the floor of the vehicle with a cable connecting on the suspension to evaluate the roughness of the road. Question number 32. Curvature correction to a staff reading in a differential leveling survey is. Curvature makes the apparent staff reading more and the object appears lower than its real level on the ground. Hence, curvature correction is negative and applied to the staff reading. So, curvature correction is given by the formula minus 0.0785 d square, where d is the horizontal distance from the point of observation to the station and curvature due to refraction is given by 0.01121 d square, and the combined correction is given by minus 0.0673 d square. So the curvature correction will be always subtractive, it is negative. Question number 33. The plan of a survey plotted to a scale of 10 meter to 1 centimeter is reduced in such a way that a line gradually 10 centimeter long now measures 9 centimeter. The area of the reduced plan is 81 centimeter square. The actual area of the survey is, so it is 10,000 meters square. So the right answer is option A. Question number 34. The type of the surveying in which curvature of the earth is taken into account is called. When the true shape of the earth, that is curvature of the earth, is considered while taking the measurements, such type of the surveys are called geodetic survey. Option A is the right answer. In this type of the survey, all the lines lying on the surface are curved lines and they form spherical triangles. Question number 35. The plan of the map was photocopied to a reduced scale such that a line originally 100 mm measures 90 mm. The original scale of the plan was 1:1000. The revised scale is. So first let us determine the shrinkage factor of the map. So it is 0.9. Therefore reduced scale is equal to, so the reduced scale will be 1:111. So the right answer is option B. Question number 36. Maximum possible value of the compaction factor for fresh or green concrete is. Compaction factor is the ratio of weight of partially compacted concrete to the weight of fully compacted concrete. So it is evident that weight of partially compacted concrete which never exceeds weight of the fully compacted concrete. So the maximum value of the compaction factor is 1. Option B is the right answer. Question number 37. Which one of the following is categorized as long-term loss of pre-stress in a pre-stress concrete member? So the long-term loss is due to relaxation of strands. Relaxation is assumed to mean the loss of stress in steel under nearly constant strain at a constant temperature. So it is similar to the creep of concrete. Option C is the right answer. Question number 38. The cross section of a thermomechanically treated reinforcing bar as. Thermomechanically treated bars are subjected to atmospheric cooling to equalize the temperature difference between inner core and exterior core. Once the TMT bar cools down, it slowly turns into ferrite perlite mass with a hard martensitic rim. So the right answer is option C. Question number 39. As per Indian Standard Code Practice for Pre-stress Concrete IS 1343-1980, the minimum grade of concrete to be used for post-tension and pre-tension structural elements are respectively. So the minimum grade of concrete used for a post-tension is 13 MPa and for pre-tension is 40 MPa. So option D is the right answer, M30 and M40. Question number 40. The partial factor of safety for concrete as per IS 456-2000 is. For concrete, factor of safety is 1.5 and for steel, factor of safety is 1.15. Factor of safety for concrete is greater than factor of safety for steel. This is because of higher variability associated with concrete, that is, quality control of concrete is not as good as that of steel. So as per IS 456-2000, the partial safety factor of concrete is 1.5. Option A is the right answer. Question number 41. Bernoulli's equation is applicable for. Bernoulli's equation is applicable when the flow is incompressible, irrotational and steady and the fluid is ideal, that is, viscosity is 0. So it is applicable for inviscid and incompressible fluid flow. Option C is the right answer. Question number 42. The Le Chatelier apparatus is used to determine. This apparatus is used to determine soundness of the cement. Option D is the right answer. In the following figure, you can observe the Le Chatelier apparatus used to determine the soundness of cement. Question number 43. The deformation in concrete due to sustained load is creep. Option A is the right answer. This deformation usually occurs in the direction of applied force, thus causing the permanent deformation in the concrete structures. Option A is the right answer. Question number 44. The width of the square footing and the diameter of the circular footing are equal. If the both footings are placed on the surface of the sandy soil, the ratio of ultimate bearing capacity of the circular footing to that of square footing will be. So, for a circular footing, the bearing capacity is given by, so when the footing is placed on the sandy soil, cohesion will be 0 and depth of the footing will be 0. Therefore, ultimate bearing capacity of a circular footing will be 0.3 times of gamma b into n gamma. So this is for a circular footing. And for a square footing, the ultimate bearing capacity is given by, so when the square footing is placed on the sandy deposit, its cohesion will be 0 and depth of the footing will be 0. Therefore, ultimate bearing capacity will be 0.4 times of gamma into b into n gamma. This is for square footing. Let us consider this as equation 1, this as equation 2. So, the required ratio will be 0.3 gamma b n gamma divided by 0.4 gamma b n gamma. On solving this, the ratio will be 3 by 4. So option C is the right answer. Question number 45. There are 20,000 vehicles operating in a city with an average annual travel of 12,000 km per vehicle. The nitrous oxide emission rate is 2 gram per kilometer per vehicle. The total annual release of nitrous oxide will be, where the average annual daily emission per vehicle is equal to emission per kilometer of travel into distance travelled in kilometer multiplied by number of vehicles, be 4,80,000 kg. So the right answer is option A. Question number 46. The setting time of a cement is determined by using. In the following figure, you can observe the Vicat apparatus, which is used to determine the initial and final setting time of the cement. Option C is the right answer. Question number 47. The clay mineral whose structural units are held together by potassium bond is illite. Option B is the right answer. It is a combination of 2 silica and 1 alumina sheet which are held together by ionic bond, which is stronger than the van der Waals forces but weaker than hydrogen bond. So the right answer is option B, illite clay mineral. Question number 48. Dupit's assumptions are valid for. Dupit's equations are used to compute the discharge through an unconfined aquifer. Option D is the right answer. Question number 49. A flow net below a dam consists of 24 equipotential drops and 7 flow channels. The difference between the upstream and downstream water levels is 6 meter. The length of the flow line adjacent to the toe of the dam at exit is 1 meter. The specific gravity and void ratio of the soil below the dam are 2.7 and 0.7 respectively. The factor of safety against piping is. Let us write down the given data. Number of flow channels is 7. Number of potential drops is 24. The difference between the upstream and downstream water level is 6 meter. And the specific gravity is 2.70. And void ratio is given as 0.7. These are the given data. So the factor of safety against piping is calculated by the ratio of critical hydraulic gradient to the hydraulic gradient, which is given by G. So the factor of safety against piping will be 4. 6 fours. So the right answer is option D. Question number 50. For a given discharge in an open channel, there are 2 depths which having the same specific energy. These 2 depths are known as critical depths. Option B is the right answer. This critical depth is the condition of minimum specific energy known as critical flow conditions. So this completes the part 1 questions of this question paper. Now let's begin with part 2 questions. Question number 51. The state of 2-dimensional stress acting on the concrete lamina consists of direct tensile stress, 1.5 Newton mm square along x direction and the shear stress of 1.20 Newton per mm square, which causes cracking of concrete. The tensile strength of the concrete in Newton per mm square is. So let us draw a free body diagram. So for the given state of stress, the maximum tensile strength of the concrete is given by 2.170 Newton per mm square. Option C is the right answer. Question number 52. In a two-dimensional stress analysis, the state of stress at a point is shown below. If S is equal to 120 MPa and T is equal to 70 MPa, then stress along x direction and y direction are respectively. So in the following figure, let us find the distance between AB, that is 4 meter, and angle cos theta is equal to 4 by 5, sin theta is equal to 3 by 5. Considering the force along x direction 0, on solving this, stress along x direction is equal to 270 divided by 4, which is equal to 67.5 MPa. Considering the force along y direction is equal to 0, stress along y direction will be 634 divided by 3, which is equal to 213.33 MPa. So the right answer is option C. Question number 53. For a linear elastic beam shown in the figure, the flexural rigidity EI is equal to 781,250 kN meter square. When the intensity of the load W is equal to 10 kN per meter, the vertical reaction RA at point A is equal to 50 kN. The value of RA for load W is equal to 100 kN meter is. This is a cantilever beam with a fixed end at point A, which is resting on a rigid platform with a 6 mm gap of a length 5 meter. So in the question it is asked to find the vertical reaction due to change in load. For intensity of the load 10 kN per meter, the vertical reaction at point A will be 50 kN. If the intensity of the load is changed to 100 kN per meter, they are asking to find the vertical reaction at point A. So in order to determine this, first we have to find the deflection due to 10 kN meter load. It is given by the formula WL to the power of 4 8 EI. W is the intensity of the load, that is 10 kN per meter. L is the length of the cantilever beam, that is 5 meter, so 5 to the power of 4. EA is the flexural rigidity 781,250 kN meter square. On solving this, deformation will be 1 mm, which is less than 6 mm gap. So if the intensity of the load is changed to 100 kN meter, deflection or deformation due to 100 kN per meter will be 10 mm, which is greater than 6 mm. This exceeds the gap between the rigid platform. Reaction at point B is equal to deflection prevented at point B. The reaction at point B will be 75 kN. Now to find the reaction at point A is equal to 100 into 5 minus reaction at point B, which is equal to 500 minus 75, that is 425 kN. So the right answer is option B, 425 kN. Question number 54. A circular solid shaft of a span L is equal to 5 meter is fixed at one end and free at other end. A twisting moment of T is equal to 100 kN meter is applied at the free end. The torsional rigidity GH is equal to 50,000 kN meter square per radian. Following statements are made for this shaft. Statement number 1. Maximum rotation is 0.01 radians. statement number 2, the torsional strain energy is 1 kilonewton meter. So here we have to calculate maximum rotation and torsional strain energy of a circular solid shaft with the following data, and then we have to decide which statements are true or false. From the torsional equation we know that the maximum rotation, that is theta, is equal to T into L divided by G into J. T is the twisting moment, that is 100 kilonewton meter, so 100 into 10 to the power of 6. L is the span length of the solid circular shaft, that is 5 meter, so 5000 divided by torsional rigidity of 50,000 kilonewton meter square per radian, so 50,000 into 10 to the power of 6. On solving this, the maximum rotation will be 0.01 radians. So the first statement is correct. Now we have to find the torsional strain energy. Twisting moment is 100 kilonewton meter, so 100 into 10 to the power of 6. Angle of rotation is 0.01 radians. On solving this, the torsional strain energy will be 0.5 kilonewton meter. So the second statement, it is given as 1 kilonewton meter, and we got the torsional strain energy as 0.5 kilonewton meter. So first statement is true, second statement is false. So with the reference of above statements, the right answer will be option B. Statement 1 is true and statement 2 is false. Question number 55. The coefficient of permeability of a soil in horizontal and vertical directions are 3.46 and 1.5 meter per day respectively. The base length of the concrete dam resting in the soil is 100 meter. When the flow net is developed for this soil with 1:25 scale factor in the vertical direction, the reduced base length of the dam will be B is equal to square root of coefficient of permeability along y direction divided by coefficient of permeability along x direction multiplied by the base length of the concrete dam. So transformed horizontal distance will be 65.843 meter. As the scale factor is given as 1:25, the reduced base width to the scale will be 65.843 divided by 25, which is equal to 2.63 meter. So option A is the right answer. Question number 56. The critical slip circle for a slope is shown below along with the soil properties. These are the soil properties. The length of the arc of a slip circle is 15.6 meter and the area of the soil within the slip circle is 82 meter square. The radius of the slip circle is 10.3 meter. The factor of safety against the slip circle failure is nearly equal to. So we have to determine the factor of safety. Factor of safety is determined by resisting moment divided by actual moment, where resisting moment is given by the formula C into L into R, and actual moment is divided by total weight multiplied by horizontal distance, where W is the weight of the soil inside slip circle, which is equal to area multiplied by its unit weight. Area is 82 meter square, it is given, and its unit weight is 20. So the total weight of the soil inside the slip circle will be 1640 kilonewton. On solving this, the factor of safety will be 1.28. So option D is the right answer. Question number 57. A plate load test was conducted in a sand on 300 mm diameter plate. If the plate settlement was 5 mm at a pressure of 100 kPa, the settlement in mm of a 5 meter by 8 meter rectangular footing at the same pressure will be. So settlement of the footing will be 5 into 3.559, which is equal to 17.8 mm. So option D is the right answer, 17.8 mm. Question number 58. If the effective shear stress strength parameters of a soil are C dash is equal to 10 kilopascal, phi is 30 degree, this is the angle of internal friction, the shear strength on a plane within saturated soil mass at a point where the total normal stress is 300 kilopascal and the pore water pressure is 150 kilopascal will be. So we have to determine the shear strength of a soil. Effective normal stress will be total normal stress minus pore water pressure, that is 300 minus 150 kilopascal, which is nothing but 150 kilopascal. So shear strength is 96.6 kilopascal. So the right answer is option B, 96.6 kilopascal. Question number 59. A valley curve has a descending gradient of 1 in 40 followed by ascending gradient of 1 in 50. The length of the valley curve required for a descent speed of 80 km per hour for the comfort condition is. As per the comfort condition, the length of the valley curve is calculated by the formula 2 times of nb cube divided by c to the power of 1 by 2, where n is the rate of change of gradient, that is 0.045, where v is the descent speed of the vehicle, which is given as 80 km per hour. So to calculate the length of the valley curve, it should be taken in meter per second, so which is equal to 22.22 meter per second, and c is the rate of change of acceleration. For the comfort condition, let us assume as 0.6 meter per second square. By substituting these values, the length of the valley curve will be 57.44 meter. Option C. Question number 60. The radius of relative stiffness for a 20 cm thick slab with Young's modulus of elasticity 3 into 10 to the power 5 kg per centimeter square and Poisson ratio of 0.15 resting on a subgrade having a modulus of 5 kg per centimeter cube is. So we have to find the radius of relative stiffness. It is given by the formula L is equal to EH cube divided by 12K 1 minus mu square to the power of 1 by 4. Therefore, radius of relative stiffness will be 79.99 centimeter, which is equal to 80 centimeter. So the right answer is option B. Question number 61. A car is moving at a speed of 72 km per hour on a road having 2% upward gradient. The driver applies brakes when he sees an obstruction. If his reaction time is 1.5 seconds, assuming that the coefficient of friction between the pavement and tire is 0.15, calculate the distance traversed before the car finally stops. So we have to determine the safe stopping side distance. As per IRC, the safe stopping side distance of a vehicle is given by the formula. On substituting these values, the safe stopping side distance will be 150 meter. Option B is the right answer. Question number 62. The design speed of a national highway is 100 km per hour if the maximum permissible super elevation is 0.1 and the coefficient of lateral friction is 0.15. The ruling minimum radius of a horizontal curve on a highway should be. As per IRC, the formula to find the ruling minimum radius of a horizontal curve is E plus F is equal to V square divided by 127 R. The rate of ruling minimum radius of horizontal curve will be 314.960 meter. So it is nearly equal to 315 meter. Option B is the right answer. Question number 63. A roundabout is provided with an average entry width of 8.4 meter. Width of the weaving section is 14 meter. Length of the weaving section between the channelizing island is 35 meter. The crossing traffic and total on the weaving section are 1000 and 2000 PCU per hour respectively. The nearest rounded capacity of the roundabout in PCU per hour is. So we have to determine the capacity of the rotary or turnabout, which is given by, where W is the width of the weaving section 14 meter, L is the length of the weaving section 35 meter, E is the average entry and exit width 8.4 meter, P is the proportion of weaving section which is given by the ratio of crossing traffic to the total weaving section traffic. So crossing traffic is 1000 and total weaving section traffic is 2000. So the proportion of weaving traffic is 0.50. On substituting these values, the capacity of the rotary or turnover board will be 3733.33 PCU per hour, which is equal to 3700 PCU per hour. So the right answer will be option B. PCU means passenger car unit per hour. Question number 64. A crest vertical curve joins two gradients of +3% and -2% for a design speed of 80 km per hour and the corresponding stopping side distance of 120 meter. The height of the driver's eye and the object above the road surface is 1.2 meter and 0.15 meter respectively. The curve length, which is less than the stopping side distance to be provided, is. So we have to determine the curve length, which is nothing but length of the vertical curve. Assuming length of the vertical curve should be greater than stopping side distance, length of the vertical curve will be calculated by the formula 2 into S minus square root of 2 into H plus square root of 2 into small h square divided by n. N is the gradient, S is the stopping side distance. Stopping side distance is given as 120 meter, so 120 meter square root of 2 into h. H is the height of the driver's eye, that is 1.2 meter plus square root of 2 into h. H is the height of the object above the road surface, that is 0.15 meter. N is the rate of change of gradient between the upward and downward gradient, that is +3% and -2%. So it will be 0.05. On solving this, the length of the vertical curve will be 152.05 meter. So the right answer is option B. Question number 65. The observation from a closed loop traverse around an obstacle are given in the following table. These are the 5 different segments with corresponding length and azimuth angles. What is the value of the missing measurement? So here for the segment PQ, the length is missing. We know that for a closed loop traverse, the summation of latitude and summation of departure is equal to 0. So let us find the latitudes for each different segments in the closed loop traverse. So for a closed loop traverse, summation of latitude is equal to 0. That is L cos 33.75 plus, if you add these values, the sum will be minus 329.913, which is equal to 0. Therefore L is equal to 329.913 divided by cos 33.75. On solving this, you will get length as 396.790 meter. Option B is the right answer. Question number 66. The design speed for a 2-lane road is 80 km per hour. When a design vehicle with a wheelbase of 6.6 meter is negotiating with a horizontal curve on that road, the off-tracking is measured as 0.096 meter. The required widening of a carriageway of a 2-lane road on the curve is approximately. We have to determine the rate of extra widening. So as per IRC, the rate of extra widening width is given by NL square divided by 2R plus V by 9.5 square root of R. So from the off-tracking relationship, we have to determine the radius of horizontal curve, which is given by the formula L square divided by 2R. Off-tracking is a phenomenon of a rear wheel not following the front wheel while negotiating the curve. So off-tracking is given as 0.096 meter. L square, L is the length of the wheelbase, that is 6.6 meter. So 6.6 square, 2 times of R. So 2R is equal to 6.6 square divided by 0.096. On solving this, the radius of horizontal curve will be 226.875 meter. Now by substituting this value in the extra widening width formula, extra widening width will be 0.7510 meter. So option C is the right answer, 0.75 meter. Number 67. The calcium concentration and magnesium concentration of a water sample are 160 mg per liter and 40 mg per liter as their ions respectively. The total hardness of a water sample in terms of calcium carbonate in milligram per liter is approximately equal to. So total hardness of a water sample is given by magnesium concentration is 40, equivalent weight of magnesium is 12, equivalent weight of calcium carbonate is 50, calcium concentration is 160 mg per liter, equivalent weight of calcium is 20 and equivalent weight of calcium carbonate is 50. So the total hardness of a water sample will be 166.67 mg per liter plus 400 mg per liter, which is equal to 566.67 mg per liter. So option D is the right answer. Question number 68. A wastewater sample has an initial BOD of 222 mg per liter. The first order BOD decay coefficient is 0.4 per day. The BOD consumed in milligram per liter in 5 days is equal to. So we have to determine the ultimate BOD of a sample at 5 day. So it is given by the formula BOD at 5 day consumption is equal to initial BOD into 1 minus e to the power of minus k into t. BOD at 5 days will be 191.95 milligram per liter. So the right answer is option B, 192 milligram per liter. Question number 69. For a water treatment plant having a flow rate of 432 meter cube per hour, what is the required plan area of a type 1 settling tank to remove 90% of the particles having settling velocity of 0.12 cm per second? So let us write down the given data. Flow rate is given as 432 meter cube per hour. We shall convert it into seconds, meter cube per second. So 432 divided by 60 into 60 meter cube per second. So 0.12 meter cube per second. Efficiency of removal of the bacteria is 90%. So 90% is equal to settling velocity divided by overflow velocity into 100. Settling velocity is given as 0.12 centimeter per second. Overflow velocity we have to find. Therefore overflow velocity will be 0.133 centimeter per second. Therefore area of the settling tank is given by flow rate divided by overflow velocity. Flow rate is 0.12 meter cube per second. Overflow velocity is 0.133 centimeter per second. to convert it into meter, 0.13 divided by 100. On solving this, the area of the settling tank will be 90.225 meters square, which is equal to 90 meters square. Option C is the right answer. Question number 70. An ideal horizontal flow settling basin is 3 meter deep, having a surface area of 900 meters square. Water flows at the rate of 8000 meter cube per day at water temperature of 20 degrees Celsius. N is equal to 10 to the power of 3 kg per meter second and unit weight is equal to 1000 kg per meter cube. Assuming Stokes' law to be valid, the proportion of spherical sand particles 0.01 mm in diameter with a specific gravity of 2.65 that will be removed is. So we have to determine the percentage of removal. We know that surface overflow rate is given by discharge by area of the settling tank. So discharge is given as 8000 meter cube per day. So 8000 divided by 900 is the surface area. So surface overflow rate will be 8.99 meter per day. Now settling velocity is given by the Stokes formula, Gd square divided by 18 mu into Gs minus 1 into unit weight of water. So G is the acceleration due to gravity, D is the dia of the spherical particle, 0.01 mm. So to convert it into meter, 0.01 divided by 1000. Gs is the specific gravity of the particles, so it is given as 2.65. Unit weight of the water is 1000 kg per meter cube, so 1000 divided by 18 into mu is the coefficient of viscosity, so 10 to the power of minus 3. This must be coefficient of viscosity mu, 10 to the power of minus 3 kg per meter second. On solving this, the velocity of the settling particles will be 8.9925 into 10 to the power of minus 5 meter per second, which is equal to 8.9925 into 10 to the power of minus 5 into 24 into 60 into 60 to convert it into meter per day, which will be equal to 7.770 meter per day. Now to calculate the percentage of removal, velocity of the settling particle divided by surface overflow rate into 100, which is equal to 7.770 divided by 8.990 into 100. So the percentage of the removal will be 87.406%. So it is nearer to 87.5. Option C is the right answer. Question number 71. A 15 cm length of steel rod with a relative density of 7.4 is submerged in a 2-layer fluid. The bottom layer is mercury and the top layer is water. The height of the top surface of the rod above the liquid interface in centimeter is. So let us consider the top layer is water of a depth x meter and the bottom layer is submerged with mercury. This is water, this is mercury of depth 15 minus x meter. 15 cm is the total length of the steel rod. This is total 15 cm length. A is the area of the steel rod section with a relative density of 7.4, which is equal to x into 1 into A plus 15 minus x into area into 13.6 is the relative density of mercury. So x is equal to 7.380 meter. So option D is the right answer. Question number 72. In a 1/50 model of a spillway, the discharge was measured to be 0.3 meter cube per second. The corresponding prototype discharge in meter cube per second is. Model discharge is given as 0.3 meter cube per second. Prototype discharge we have to find. Scale ratio is given as 1/50. So we know that relative discharge is equal to scale ratio to the power of 5/2. Relative discharge is ratio of model discharge divided by prototype discharge. Scale ratio is 1/50th model. So 1/50 to the power of 5/2. Model discharge is given as 0.3 meter cube per second. So 1/50 to the power of 5/2. Therefore, prototype discharge will be 0.3 divided by 1/50 to the power of 5/2. On solving this, the prototype discharge will be 5303 meter cube per second. So option D is the right answer. Question number 73. A solid sphere of diameter 6 mm is rising through oil of mass density 900 kg per meter cube, dynamic viscosity of 0.7 kg per meter second at a constant velocity of 1 cm per second. What is the specific weight of the material from which the sphere is made? So we have to determine the specific weight of the material. In the dynamic equation condition, upward force is equal to downward force. Upward force is nothing but buoyant force, and the downward force is the sum of weight of sphere plus drag force. Buoyant force is given by density of the oil, volume of the sphere into acceleration due to gravity. Weight of the sphere is density of the sphere, volume of the sphere into acceleration due to gravity. Drag force is half times of coefficient of drag, density of the sphere, area of the sphere into constant velocity. So first let us find out the volume of the sphere, that is given by 4/3 pi r cube, where r is the radius of the solid sphere. So 4/3 pi into 0.03 cube, which is equal to 1.131 into 10 to the power of minus 7 meter cube. Now we have to find the coefficient of drag. CD is equal to 24 by Reynolds number, where Reynolds number is given by constant velocity v into diameter of the solid particle or a solid sphere divided by dynamic viscosity by mass density. Dynamic viscosity is 0.7, mass density is 900 kg per meter cube. So Reynolds number is equal to 0.01 into 0.006 divided by 0.7 divided by 900. So Reynolds number will be 0.0771, which is less than 1. By substituting this Reynolds number, the coefficient of drag will be 311.284. A is the area of the solid sphere, which is given by pi r square. So pi into 0.003 square, which is equal to 2.82 into 10 to the power of minus 5 meter square. On substituting all these values in the following equation, you will get square. On solving this equation, you will get 9.98 into 10 to the power of minus 4, which is equal to 1.109 into 10 to the power of minus 6 into density of the sphere plus 3.964 into 10 to the power of minus 4, which is equal to 5.32 kilonewton per meter cube. So the right answer will be option B, 5.3 kilonewton per meter cube. Question number 74. A velocity field is given as the following equation, where x and y are in meters. The acceleration of the fluid particle at x comma y is equal to 1 comma 1 in the x direction is. So we have to determine the acceleration in x direction. The given velocity field equation is 2y I 3x j, where u is equal to 2y and v is equal to 3x. Dou u by dou x is equal to 0. Dou u by dou y is 2. Dou u by dou t is 0. Therefore, acceleration along x direction is given by, so u is 2y, dou u by dou x is 0, v is 3x, dou u by dou y is 2, dou u by dou t is 0. So 3x into 2, which is equal to 6x. So at a point x comma y is 1 comma 1. So substituting the value of x at a point 1, acceleration along x direction will be 6 meter per second square. So the right answer is option C. Question number 75. The height of the hydraulic jump in the stilling pool of 1:25 scale model was observed to be 10 cm. The corresponding prototype height of the jump is. The model height of the hydraulic jump will be 10 cm and the scale ratio is 1:25. So we know that the ratio of model height divided by prototype height is equal to 1:25. That is the scale ratio of the hydraulic jump. So the prototype height will be equal to model height divided by 1/25, which is equal to 250 centimeter. Since the given options are in terms of meter, the height of the prototype will be 2.5 meter. Option B is the right answer. So this completes the part 2 questions of this question paper. I hope all the solutions and information provided for this question paper is satisfied for your examination preparation. Thanks for watching this video.